Number 13, to choose the R value that best describes the data. So if we look at the graph, the sign of the R value is the same as the sign of the slope. So the slope here is negative, it's trending down. So the R value has to be one of these negative values, either B or C. And then the more close together these points are on a line, like the tighter fit they are on a line, the closer the R value is to 1. Whereas the more scattered the points are, the closer to 0 the R value is. So these points are all pretty, they're not, obviously if you connect all the dots together it wouldn't be a straight line, but there's clearly a trend. It's pretty strong, clearly going down. Clearly we can see what's going on here. So this is going to be negative 0.9 because it's not all that scattered. So 14, choose the equation of the line of best fit. So here I'm just going to start graphing these lines, and whichever one best fits that data will be the best choice for line of best fit. So the first one, the y-intercept is 12, and we're going down by 1 and over 1. Now be very careful. Notice that one box is actually 2. So to go down 1 over 1, we're going to go down half over 1, down half over 1, 1, 1, 1, 1. So here, that's probably not the best bet. So that's F. Okay, then G, we're starting at 10, and then the slope of negative 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Likewise, the slope isn't quite right. It's not quite steep enough. Then H, we're starting up at 12. We're going down 2 over 1. So down 2 is one box, and then over 1, 2 and 1, 2 and 1, 2 and 1, 2 and 1. So that looks pretty good. That looks like a pretty good line. We'll see if any of them are any better. I starts at 10 and has the same slope. So that's too low. It's just below all the data. It doesn't go through it at all. And then J having a positive slope, we can actually rule that out right away. Clearly this is trending negatively, so it can't be J. So it looks like H is the best choice. So 15, interpret the meaning of the slope in the context. So my strategy for the slope, if it's not clear just on by looking at it, remember that slope is your change in y over your change in x. So look at the units for the y and the units for the x, and that'll give you some insight. So for example, our slope is negative, so we can say that we're decreasing. So something is decreasing. And if we need to reword it after we write one thing down, we can do that. But so our slope is the negative 2. So in the context, this means we're decreasing 2 y's, which are incorrect notes. So we're decreasing 2 incorrect notes per x, or per hour. So the strategy is to basically turn that notation, that xy notation, into unit per unit. So our slope means we're decreasing 2 incorrect notes per hour. 16, now we're going to use the equation to predict how many hours someone spent practicing if they played 9 incorrect notes. So this is a where we're given either x or y, and then we're going to use the equation to find the other unknown, or the other variable, which is our unknown. So we're given the number of notes, and that is y. We know it's y because if we look at our graph, the number of notes is the y-axis. So in this case, we're going to plug 9 into y of the equation. Again, h is our equation. Negative 2x plus 12. And x is the number of hours, so it makes sense that that's our unknown. So now we'll solve for x. Move the 12 over. Get negative 3 equals negative 2x. So we can divide by negative 2. So x equals 1.5, and that is hours. Now if you look at your graph, that makes sense. If you go to 1.5 on the x-axis, right here and go up until you hit your line, that's about 9. So that makes sense. Okay, and now number 17. Here we're going to predict how many incorrect notes, that's y, given that we practiced 2.5 hours. So that's the x. So in this case, we're going to say y equals -2 times 2.5 plus 12. And so here it's already solved. We just need to simplify all this. That's going to give us 7. In this case, it's 7 incorrect notes.